Hi everyone, it is an honor to introduce our next speaker. She is a remarkable figure in the teaching profession with over 19 years of experience teaching postgraduate students. She is also the assistant professor in the Master of Computer Applications department at KLS Gopti Institute of Technology in India. She is also very actively involved in the Python community. Today, she'll be delivering a talk to us on the topic Loop Less, Map More. Rethink how you iterate in Python. Everyone, please help me welcome on stage Swaroprani Mano. Thank you.
Hi everyone, thanks for joining me today. Whether you are just starting with the Python or you have been coding for years, we all love loops, right? But what if we could loop less and still get the job done? That's where map can help us. I have been teaching Python for over a decade. I write articles on LinkedIn and Quora Kannada, run a newsletter called Python Unlock Your Skills on LinkedIn platform, and I organize Python workshops, webinars, hackathons. Over the years, I have learned that the key to writing clean, efficient code is knowing when to use the right tool. So today I'm going to show you when to use which one, when to stick with loop and when to try map, and how this small change can make your code cleaner, faster, and easier to maintain. So, by the end of this session, you will know how to loop less and map more. So, let's get started. As Python developers, we all use loops, right? Because whenever we have repetitive tasks to be done, we depend on loops. They help us go through lists, dictionaries, and other collections. So on the screen, you can see that we have a list of temperatures and we need to convert them from Celsius to Fahrenheit. And a loop can do that for us, right? Loops make repeating tasks easy. Instead of doing the math for each temperature, the loop takes care of it. We have just used a for loop, and the temperature variable is going to fetch one temperature from the Celsius list, and there is a formula that converts the temperature to Fahrenheit, and we are appending it to a list, and finally we are printing that. So that's cool, right? But when your data grows or the task becomes more complex, loops can slow down. Here we hardly have a list of 5 elements. Let's take 100 elements or 1000 elements, that's fine. But what if we have a million of data to be processed? Loops can slow down and they can get harder to manage also. That's when map comes in. So Python is very beautiful. It provides us a lot of tools to process our data and make the things easier. Because map is faster, we are going to use this in the next slides, and that uses less code as well. So in the next slides, we will see how map works faster than a loop. All right, now let's explore the math function. Math function allows us to transform or process every element in a collection without using explicit loops. You can see the syntax on the screen here. It takes two arguments. One is the function and other one is the iterable. It applies the function to each item in the iterable and returns an iterator with the transformed data. So that's the beauty of map function. So basically map handles the looping for you, and applies the transformation to each item in the collection. It's more cleaner way to do the same thing you would do in a loop. Now let's take a look at how we can use map to do the temperature conversion that we saw earlier. So here we have two set of programs to convert the temperature. On the left, we are using the loop. We manually iterate through the list and append the result to a new list. On the right, using map, we let the map function automatically apply the conversion function to each element in the list. After that, we simply convert the result into a list that's for the display. So with map, we avoid writing the loop ourselves, which makes the code shorter and more readable. You can notice that we uh, we are actually reducing the code here. Instead of going for a loop, we have just written a function, and that function is applied to each element in the list. So let's explore some other examples where we can use map, which can simplify our code. We have two simple programs here. In the first program, we are doubling each number in a list. We have a list of numbers. There is a function to double that, which will return the doubled result, and that gets stored in the doubled object. And finally, to display a list, we are calling the list function. And on the right, uh, the what we are doing is a list of strings has been taken and they are transformed into uppercase using the built-in string.upper method. Notice how clean and direct the code looks with map, isn't it? By using map, we can focus on what we want to do with the data and not how to loop through it. So this makes our code cleaner and it is more readable too. Now let's take a closer look at another tool that works well with map, the lambda function. It allows us to simplify our code even further. We will see how that works in the next slide. All right, we have seen how map works with predefined functions, but sometimes we need to write a function for a very specific task, and defining it separately feels unnecessary, isn't it? So, this is where lambda function comes in. A lambda is a small anonymous function that we can write inline. Here we have two approaches. On the left, we use a predefined function square with map, and on the right, we have replaced it with lambda. Notice how the lambda makes the code shorter and just as effective. Lambda is great for quick one-time tasks, but for more complex logic, sticking with a named function might be better, right? So this slide basically gives you an idea how lambda can simplify the task even better, much more easier, right? We need not have to define a separate function, call the function, which works on each element of the list and gives the result. We have just used map with lambda. That's very beautiful. So in the next slide, let's explore a few more practical examples of map with lambda. Here you can see that a couple of quick real world examples. First is applying discounts. Imagine there is a 10% discount on products. It's super easy to calculate the discounted prices with map. And next we have masking email addresses. With map and lambda, we can hide parts of the email for privacy all in one line of code. These examples show how map can simplify everyday tasks. So now you might be thinking, couldn't we just use a loop for this? And yes, we could. But here is the catch. As the list grows, loops can slow down. In both of these examples, we have a list with limited number of elements. In the first example where we apply discounts, the prices list has hardly 3 elements. And in the second approach where we are masking the email addresses, there are hardly 2 email addresses, even if they have hundreds of thousands of elements. Loops work fine. But as the loop grows, imagine you have millions of elements to be processed. Loops can slow down. So, in the next slide, we will see a comparison that highlights the performance between map and the loops. So, here we have a very simple and beautiful example that shows the performance of loops and map function. We are working with a list of 1 million numbers here. First, we define a simple function square. The task is to square the number. Then we apply it to a list of 1 million numbers using map function. And we have imported a time module here. This is to calculate the time taken to perform the task. Okay, so at the end, the time taken by this method is printed. In continuation with this, here we apply the same square function which contains a list of 1 million numbers, but this time we are using a for loop. And again, the time taken by this method is also printed at the end just to see the comparison. Okay, so both are doing the same task, but what is the result? So here is the result. When I ran this code on my machine, this is what I observed. Map function took 0.11 seconds and the for loop took around 0.181 seconds. As you can see, in this case, map was faster than the for loop, right? So this is a very straightforward comparison of the performance. This is because map is optimized to process data at a lower level. That gives it an edge when the list grows larger. However, the performance difference can vary. It need not be same always. It depends on the operation you are performing and the size of the data as well. So it is always a good idea to test both approaches in your specific use case. Here we are not uh, telling that for loop is not good or map is very good. It is just a performance comparison depending on the situation, the kind of operation that you are doing, and the size of the data that you are working with. It all varies, right? So it's always good to test both the approaches with your specific use case. This way, you will know which works best for your scenario. The key takeaway here is that as your data grows, tools like Map can help you process it faster, and that keeps your code clean and concise as well. All right, to wrap up, remember it is all about looping less and mapping more. Use map to apply a function to every item. No need to write extra loops. And it cleans up your code and makes it easy to follow. When your data grows, do not worry. Map can be faster and more efficient. Of course, loops are good for small things, but map is your friend when it gets bigger. And using map with Lambda, that is perfect for one-liners. We have seen beautiful examples how map works efficiently with Lambda functions for small tasks. Hope you will start looping less and mapping more in your code. Thanks for being part of today's session. Thank you so much, everyone. It's been a pleasure. Big thanks to Pi Ladies for this opportunity and hope to cross paths again soon. Happy coding. Thank you.
Thank you so much to Swawu Prani for that very engaging presentation. You have inspired us all to rethink how we iterate in Python. Thank you so much.